Synrad high-performance CO2 lasers mark many common items found in everyday life, spanning a wide array of consumer items found in grocery stores through industrial parts such as PCBs and metal tags. In all cases, laser marking provides a clean, legible, and permanent mark. One of the most common Synrad laser marking applications is putting traceability codes and expiration dates on consumer packaging, otherwise known as coding. With careful optimization of operating parameters, CO2 laser coating on consumer packaging offers many advantages over traditional marking methods, such as continuous inkjets. Laser coating eliminates costly consumables, such as ink, and maintenance time for cleaning clogged nozzles. In fact, mark legibility and consistency is much better compared to inkjet technologies as seen in this example. To determine the maximum line speed for coating, the laser power needs to be considered. Laser powers of 10 to 30 watts are most common, but may go up to 60 watts for the fastest throughput requirements. Careful consideration is required to determine optimal CO2 laser wavelength to use. For best throughput and mark quality, understanding the specific material's absorption characteristics are critical. In the case of PET bottle coating, the 9.3 micron wavelength has superior absorption on the surface of the substrate, leading to a high contrast white mark while eliminating puncture danger in thin-walled bottles. Another example is coating on polypropylene laminated chipboard boxes, a common packaging material in pharma. The marks made by 10.6 micron are melted and faded, whereas at the 10.2 micron wavelength, marks are crisp and clear due to the stronger absorption in polypropylene. Another major category is direct part marking. The 9 to 11 micron wavelength of Synrad lasers are ideal for directly marking on wood, coated metals, and window glass, among others. Laser marking glass is a very flexible method of creating dynamic marks on door and window glass. This eliminates the constraints and mess associated with using static masks and sandblasting. 30 watts of laser power is typically used for simple regulatory marks, while pulsed lasers like the P100 and P150 may be used for frosting the glass with complex images. Wood can be laser marked on the surface with good dark color contrast, or vaporized to a certain depth to create 3D engraved image. The image clarity and detail is much higher than traditional heat brand or CNC methods. Our VI30 or TA series lasers are a popular choice for this application and can be selected at power levels from 30 to 100 watts. While direct marking on bare metal is not usually practical, removal of paint, anodized coatings, isolation material, or other coatings from metallic surfaces are well suited to our long wavelength. In this example, we are bleaching black pigment out of the anodized coating while maintaining the protective layer. For the electronic industry, low-power CO2 lasers are ideally suited to laser marking the green solder mask on PCB boards with 2D matrix codes for traceability without exposing the copper underneath. Typical laser powers used are 5 to 10 watts. Synrad's newly released 32-1 laser is ideally suited for extremely compact PCB marking systems. This video highlighted the advantages of laser coating and marking over other processes, including lower operating costs, including lack of consumables, improved operational efficiencies, added flexibility, simplified integration with fewer components. Though laser marking and coating is well established, there are many factors to consider in choosing the best laser system for your process. Let Synrad application engineers help make the selection process easier with material and application testing to identify the optimal CO2 laser processing equipment for your specific application.